Now let's take a look at problem 2. So here's a problem definition. So we are given two companies, companies P and N, and assume that they both produce the same products. So there are M different products, and they both produce these products, but like in their own version. And company P charges PI for the product I, and company N charges NI for the same version of that product when it produces it. Now, so assume that you're a customer and you want to buy all these M products, but you want to do that such that the total price that you pay is the minimum. But there is also this, that if you buy some product I from company P and some product J from company N, then you have to pay an incompatibility cost. So you would rather buy the cheaper item, obviously, but if you keep buying different items from different companies, then you would have to pay this cost C. So the problem would come up to something like this. So if 1 to M is the indices of the products, we want to find some set S such that if we buy all the items in set S from company P and buy the rest of it from company N, and so be forced to pay this incompatibility price, then this whole thing would be minimized. So this is the S that we are looking for. And as you can see, so this is this incompatibility cost is between every pair of items from bought from company P and company N. So it's defined pairwise. And assume that like this first index comes from company P. I mean the way we define this is first index is from company P, and the second one is from company N. Okay? So this is the problem. Now, well, as I mentioned at the beginning, this problem is also a max flow mean cut problem, or at least can be interpreted that way, and that's what we want to do. So it's a minimization problem, and we are inspired to we want to model this problem with a graph in which this thing will be minimized when the mean cut of the graph is minimized. So now for that, we will consider this graph. So this is our source node, this is our sink node, and for every product type, we have a node, okay? And now the capacities of the network are, when you go from S to any other node, except T, you go with capacities P1 to Pm, if M is the number of products, and then there is an edge from all products to T with capacities N1 to Nm, which are all those prices. Also, between every two product node, there are two different kinds of edges. So one of them is, so we have edges in both directions. One of them is the cost of incompatibility between product 1 and like 2 here, and the other is the cost of incompatibility between product 2 and 1. Again, I said as we define, we assume that this first index comes from P, company P, and the second one comes from company N. So, for example, we define this side as C of 1 and 2, and we define this side as C of 2 and 1. So this is how our graph is defined. Now, what we claim here is as follows. So we claim that basically any cuts that you consider in this graph, in which one side of it contains S and the other side contains T, this will represent a way that a customer can buy these products, and the cost of the cost of that cut is going to be equal to the cost that the customer has to pay. Okay. So if you look at here, so I've considered a cut S. Cut S contains the source node S and some of the nodes that represent products. And the rest of the graph contains node T and the rest of the products. Okay. So now this is the mapping that we're going to make. I'm saying that if I have this cut S, which contains S, I will assign these, I will buy these products which are in S from company N, and I will buy these products which are in V except S from company P. Okay, now let's see what the prices have to be. Okay, so assume that this is the way I buy things. For a second, just forget about the graph. So what will happen? I will have to pay the price of these. So I will have sigma of Ni for I in N, right? And I will have to pay the price of these products in P. So it will be sigma of I in P, Pi. And I will have to pay the pairwise incompatibility price. So between any pair that is from this one to this one, I will be paying the incompatibility cost. So this one is, okay, the way I defined C, these two should be interchanged, but it's not really important. So this is the pairwise incompatibility cost between N and P. Okay, so this is what I will have to pay if I decide to buy these products in S from N and these products in V except S from P. Okay, now let's take a look at the cost of this cut in this graph that we defined. Okay, so there are three types of edges that come that go from S to the rest of the nodes. One of them are from the ones which go from S to products in V minus S. And well, as we define the graph here, as you can see, we define these capacities to be Pi. So here we'll be paying Pi for every I in P. Okay. Here. The second type of edges is edges from products to products. And again, because of the way we define these edges between every pair of all these products. That means that here also we have products, we have every pair of them. So we should again consider this sigma. Okay, we will get to this sigma. And the third type of edges that we have in our cut is the ones from products in S to T. And again, if you look at the definition of capacities of edges here, you'll see that we have to pay an I for every product here. So as you can see, so we made a mapping between any possible way that you can buy these products from the two different companies, and we showed that the price that you need to pay is equal to the capacity of this cut. Okay. So now what? Well, we want to minimize this, right? This is exactly what we want to minimize. So now, the only thing we need to do is just simply find the min cut in this graph that we defined, right? Because the min cut is going to be, find this S such that this value is minimized. And then, so once we find the min cut, we will buy all these products in S from company N and all these products from in V minus S from company P. And so that will be the minimum, that will be the way of buying these products from the two different companies such that the price that we pay would be minimized. Okay, thank you.